Same thing here, it looks like. Yep. Okay, so, but the difference now is that it's not telling us the angle of rotation. So we're burdened with having to find that for this problem. All right. Okay. I'm going to scroll up and point to something right here. If we don't have the angle, we will have to use this formula to find, or at least draw, the angle. So the cotangent of 2 theta is A minus C over B. The cotangent of 2 theta is equal to, well, here's my A, here's my B, here's my C. So A minus C over B. Which puts us at -9 over -12, which means they're both negative. We're at 3/4. Cotangent is equal to 3/4. Here's the issue, though. This is all about 2 theta. This is not our actual theta, right? That's the turn that this conic has is theta, not 2 theta. So I'm going to draw a picture. I'm going to draw a picture of 2 theta. Okay? 2 theta, cotangent, adjacent over opposite. So this is 2 theta, not theta. Pythagorean theorem will give me a hypotenuse here of 5. Hypotenuse of 5. Okay. Now, that doesn't help me find theta, but I do know that half of that angle is going to land me in quadrant 1 for sure. Well, I'm going to take you back to your formula sheets or your double and half angle formula, which you would have done prior to this. And I'm going to take you to these 2 versions that are equal to cosine of 2 theta. So if we are told that the cosine of 2 theta using this formula is equal to 2 cosine of theta squared minus 1. Looking at this picture, I can see that cosine of 2 theta is 3/5. I can solve this equation and know what cosine of theta is. Add 1. Divide 2. Square root both sides. Oh, I should simplify it first. It's 4/5. Now I'll square root. I can see from here that the cosine of theta is going to be 2 over the square root of 5. And I also know that it's the positive version of it because if 2 theta is in quadrant 1, 1 theta must be in quadrant 1. So here's my picture of just theta. 2 root 5, and if I use Pythagorean theorem here, I will have 5 equals 2 squared plus a squared. Oh, looks like we're gonna get a 1 for that opposite side. Okay, now why did I all do that? I did that because I need to replace cosine, right? When I substitute in for my x and my y, I'm going to need what the cosine is of theta, and that is 2 over root 5. I also need to know what the sine of theta is, and that's 1 over root 5. You can rationalize them if you want to, okay? Now, if you go back to the top, maybe not the top of your notes, but go back to what we do for substitutions, right? X is equal to x prime cosine theta. Sine theta. So that means x is equal to, I think I'm going to do this one more time and factor out 1 over root 5, because then I'll have 2x prime minus y prime for x times 1 over root 5. Don't get me wrong there. Y will equal, thinking back to what we replaced y with, it's plus sign now. Okay. All right, a little bit of cleanup. X prime 1 over root 5 plus y prime 2 over root 5. All right, if I factor out 1 over root 5 here, yep, I meant y, I will have an x prime 2 y prime. Not pretty, but there's my x and there's my y, okay? Now, I'm going to rewrite this equation using this x and this y. There's my x, there's my y. So, yeah, there you go. I didn't really see it right. All right. Take a minute if you need to. That's kind of a lot. Just doing that part is a lot. So, it's a nice thing about videos. You get to pause it whenever you want. Okay. We have an 8x squared. There we go. And that's squared. So 8x squared minus 12x y plus 17 y squared. Now, since this is two pieces, I can square each piece, okay? 1 over root 5, that's going to get squared, and x prime plus 2y prime, and that's getting squared, which I could do here as well if I wanted to. Separate that and put a parenthesis, then I have that piece squared times the next piece squared. All right, and this equals 20. All right, I'm going to scroll up now. I need to rewrite this so that we can identify what shape we're working with, okay? All right, kind of got a lot going on. 8. This will be 1 over 5. This, having this squared, if you go on the side and do that, you will get 4x prime squared minus, well, if you had two of them and you were distributing, you would get a 2x prime y prime and another 2x prime y prime, and they'd both be negative. Lastly, you'd have y prime times y prime. Okay. Next, well, this one and this one, so that would be a 1/5. We're going to 2x prime squared first 1 prime minus x prime, and then prime, okay. And then we have a plus 17. 2 of these will make it 1/5. 2 of these will turn it into x prime squared plus x prime y prime. Last 4 y prime. Holy smokes. Kind of a lot. Okay. This. Well, I could distribute. Man, might as well. Actually, I noticed that absolutely everything. So okay. 2 I prime squared. Next one, I'm going to distribute minus x minus next plus 17 x prime squared plus, let's see, 17 times 4, 40, 50, 68, 68 x prime y prime, again, plus 68 y prime equals 20. All right, let's see if we got some stuff that we can combine. We have a 1/5 out front. And I have a minus 3 x prime minus prime, and then here I have 6 y prime. So my screen just locked up on me. I hate that. All the x prime y primes are gone. Next, I have $32 x squared. 24 brings me to the right 25. 8 y squareds, 32 y squareds, and 68 y squareds. You know, those y primes. I'm going to distribute the 1/5 and actually gain also 5 x prime squared and 20 y prime squared. I want it to equal 1. Right now it equals 20, so let's just divide everything by 20. Simplify. Prime squared over y prime squared over 1 equals 1. This is also an ellipse. A is 2, B is 1, C would be square root of 3, because for an ellipse, A is the largest. So 4 minus 1, yeah, square root of 3. Now, it didn't ask us to draw it. It asked for the equation, the middle term, so there it is, okay? If we were asked to graph the angle, we would find it. You know, do inverse cosine. I did know that it was a, we had a picture of, right? We made the theta value, but it was about, so there unless we asked to, but it's kind of nice to have that visual. Anyway, okay.